This is the AP Calculus 5.1 through 5.4 review, problem number 4, part A. It says evaluate the given definite integrals using the evaluation theorem showing all steps. So for letter A, first of all, looks like we have a function that is a quotient, right? But this is one of those situations where since all of the terms in the numerator are being divided by x, the first thing that I am going to do is I am going to rewrite this so that I'm looking at each separate term as its own fraction so that I can simplify this a little bit. So this is going to be equivalent to the integral from 1 to 5 of 2x squared over x plus x squared. Now the cube root of x is x to the 1/3 power divided by x, and then minus 1 over x, all of this dx. Okay, and then I can simplify that by dividing everything by x, and then I can use the reverse power rule to integrate this. So again, just still simplifying, haven't done any calculus yet. So this is still the integral from 1 to 5. 2x squared over x is just going to be 2x for my first term. X squared times x to the 1/3. Okay, well that's 2 1/3. If I subtract 1, that's x to the 1 1/3 power, or the 4/3 power. And then my third term, if the x is in the denominator, that's going to be x to the -1 power. And actually, I'm going to backtrack that. I'm going to leave that as 1 over x because that is a known derivative for us. So when we integrate that, that becomes the natural log of x. All right, so now I'm ready to actually do my integration. So my first term here is going to be, when I integrate that, is going to become x squared. The 2 in front will be canceled by the 1/2 that I would multiply by, so that term is just x squared. My second term, if I add 1 to 4/3, that's like adding 3/3 to 4/3, so that term is going to become x to the 7/3 power, and then I have to multiply in the front by the reciprocal, so 3/7. And then, as I was just mentioning before, 1 over x is a known derivative for us, and that is the derivative of natural log x. So then the integral of 1 over x is going to be ln x. And again, I am evaluating this from 1 to 5. So now I'm just going to use the fundamental theorem of calculus, plug in 5 minus plug in 1, and I will get my answer. So I am going to have 5 squared plus 3/7 times 5 to the 7/3 power plus natural log 5 minus 1 squared plus 3/7 times 1 to the 7/3 power plus natural log 1. All right, and then I go ahead and I grab my calculator and I just do the math here. And you can feel free to just type this in your calculator right as it is and get a decimal answer for a problem like this. Just make sure that you are practicing for AP in terms of making sure that you are rounding your answer correctly to 3 places past the decimal point. So my answer here is going to be 40.283. And I would definitely encourage you to type this into your calculator and make sure that you do get that answer, just so that you know that you are typing things in correctly. For letter B, we are asked to do the same thing, evaluate the definite integral using the evaluation theorem and showing all steps. Okay, now at first this looks a little intimidating because we are doing the integral from pi over 3 to pi over 2 of cosecant x times cotangent x. However, that's almost a known derivative. So I'm going to put a little note here. Remember, the derivative with respect to x of cosecant x is equal to negative cosecant x times cotangent x, right? And that's basically what we have. We just don't have the negative sign, but that's okay. That just means that when we integrate it, we need to add the negative sign in to undo it. Okay, and so again, this is why it's so important that you have those trig derivatives memorized, because when we work on integrals, we need to know them so that we can work backwards. All right, so when I integrate this function then, this is just going to be equal to negative cosecant x evaluated from pi over 3 to pi over 2. And again, if you're not sure, take the derivative of that, right? Negative would come along, and then derivative of cosecant would be negative cosecant cotangent, so the two negatives would cancel and make a positive, and we'd get right back to where we started from. So then I know that I'm correct with this. So now I'm going to use the evaluation theorem, and so this is just going to be negative cosecant of pi over 2 minus negative cosecant of pi over 3. And keep in mind, cosecant is the reciprocal of sine. Pi over 2 and pi over 3 are both known locations on the unit circle, right? So pi over 2 is the top of the circle. If I think about the unit circle and the top of the circle, the ordered pair right here is 0, 1. So the sine is 1. Therefore, the cosecant would also be 1 because the reciprocal of 1 is 1. So this ends up being negative 1. We have a chop here because minus a negative, so plus, and then pi over 3 on the unit circle is right here, and the ordered pair at pi over 3 is 1/2, comma, square root of 3 over 2. So if the sine value is square root of 3 over 2, then the cosecant would be, if we flip that over, 2 over the square root of 3, which we're going to rationalize. So if we multiply top and bottom by square root of 3 over square root of 3, then we end up with negative 1 plus 2 square roots of 3 over 3. Okay, and we could leave our answer like that, or we could make a common denominator, basically just making the negative 1 into negative 3 over 3. And then we could write this as 2 square roots of 3 minus 3 over 3. That's another way that we could write it as an exact answer. But if you grab your calculator and you type that into your calculator, 0.155 would also be an acceptable answer in its decimal approximate form.